We haven't done this one yet. How about the tangent? Let's graph y equal the tangent of x. So just like we did with sine and cosine to start with, maybe we should make a table of values. So I want you to think of the unit circle to help us figure out these values. Now remember, the x and y in my table represent the x and y on my Cartesian coordinate system, not the x and y points on my unit circle. Okay, so the x is going to refer to the angle, and the y is going to refer to the value of the tangent. And we know tangent is sine over cosine. So at 0 degrees on the unit circle, we know the sine is 0 and the cosine is 1. So the tangent, therefore, will equal 0. At pi over 4, we know that the sine and cosine were both root 2 over 2, and so dividing them by each other just gives us 1. And then at pi over 2, way up here, we know that the sine is 1 and the cosine is 0, and when we divide those, it's undefined. So we have a vertical asymptote at pi over 2. So whenever the cosine is 0, we're going to have vertical asymptotes. So that's going to happen down here as well. But let's keep moving through at 3 pi over 4. The sine and cosine are both root 2 over 2, except the cosine's negative. So when I divide those, I'm going to get a negative 1 this time. And at pi, the sine is 0 and the cosine is 1. So we get 0 again. And let me go the other way. So let's get some negative values. What if I go down this way at negative pi over 4? The sine and cosine are both root 2 over 2, except this time the cosine's positive and the sine is negative. So when I divide those, I get a negative 1. And a little bit more room here. How about if I go down to negative pi over 2? So negative pi over 2. We know that we're going to have the sine is negative 1, the cosine is 0, and once again it's undefined. So we're going to have another vertical asymptote. So let's start plotting some of these and see what happens on our graph. So as we can see that it starts to repeat itself every pi units. So the period for tangent, unlike sine and cosine, the period is just pi, not 2 pi like it was for sine and cosine. So I'm going to, let's put one here, let's put one here. So we'll say here's pi over 2, here's negative pi over 2, and negative pi. Also we know that we have values of 1, so let me mark those. And let's plot some points. So at 0, we're at 0. At pi over 4, we're at 1, so that would be right about there. At negative pi over 4, we're down at negative 1. And we know that we have asymptotes at pi over 2 and negative pi over 2. Notice the asymptotes are pi units apart, which is the period of tangent. So I know there would be another asymptote at negative 3 pi over 2 and positive 3 pi over 2. All right, so let's look at this one section between negative pi over 2 and pi over 2 for our tangent. What's happening as we get closer to pi over 2? Let's look at this on the unit circle. So here we had the sine was 0, the cosine was 1, so we got 0 for a value. At pi over 4, they both had the same value, so we got 1 for the tangent. Now what's happening is I get closer to pi over 2. The sine values, the y coordinates of that point, wind up getting closer to 1, but what's happening to the cosine values, the x coordinate for this point? It's getting closer and closer to 0, so So that means that we're taking numbers for the sign that are closer to 1, but we're dividing by smaller and smaller and smaller numbers. So what happens is you divide by a really tiny number, like a fraction, like 1 over 100. It's like multiplying by 100. So our numbers are getting bigger. So on our graph, that tells me that it's getting bigger and bigger and bigger as I get closer to pi over 2, because the cosine values are getting closer and closer to 0. So in my fraction, my denominator is getting smaller and smaller, which makes the fraction bigger and bigger. Likewise, if I'm going down here, same idea as I get close to negative pi over 2, except now my values are negative because the cosine is positive, but the sine is negative. So I'm going towards negative infinity as this goes down here. And so there's one full period of the tangent. And then it just repeats itself over and over between the asymptotes. So halfway between it's at 1, halfway between there it's at negative 1, and so it's important to put arrows on these to know that it is going towards negative infinity and positive infinity. And there's your graph of tangent. And so then you should be able to, just like we've done with sine and cosine, do some transformations with a tangent graph. And just a reminder, I won't work through the whole tangent graph, but remember, you need to factor out the coefficient. So this would become x minus pi over 4. There's no amplitude on a tangent because it goes up to infinity and down to negative infinity. But the normal period of tangent, is pi, and then we have to divide by the coefficient of x, which is 2. So the period for this one is going to be pi over 2, and this has a phase shift of pi over 4 to the right. And so with that, you should be able to see how to shift your tangent graph.